All right, grade 7. What we're going to look at is scale and scale factor. Pretty easy to look at scale. You probably have went through this before, but scale basically says for one inch on a drawing, something is 4 inches in real life. There's a very simple way to do it. So if on my drawing, say something were 3, then in real life it would be 12. Make sense? That's scale. So what are we doing with scale? We're multiplying it by 4. We're amplifying it by 4 in order for it to be in real life. So that's scale. Scale factor is slightly different. So we're going to look at scale factor just in terms of what the scale factor is. We're going to look at it in terms of area, and we're going to look at it in terms of volume. Okay, so let's grab something very simple to start off with. If I have a square and it's 1, right, and we go to a square that is 4, what is our scale factor? Well, it's 1 times the scale factor equals 4. Well, in this case, I've made it very easy for you. So F is, or your factor is going to be 4. So our scale factor is 4. But that's the formula that you would use, say if this were 2 and this were 5. You use it the same way, right? So let's just do 2 and 5 just so that you can see it. So 2 times the scale factor equals 5. Well, that means that F equals 5 over 2, right? And that would give you 2 1/2 as your scale factor. So your scale factor is 2.5. Okay, so that gives you that idea. But I'm going to erase this all off because we're going to go for scale factor to how does that change for area? Because if I factor something by a scale factor of 4, what does that do to the area of that object? We know that for the first object, this area is 1, let's just use centimeters squared. And this is actually going to be 16 centimeters squared. So you can see that even though the scale factor in terms of the sides is 4, the area is actually 16. Now there is a correlation there because your area is your scale factor squared. Now here's your little thing to remember, that area always finds square centimeters. So square factor, scale factor squared will find you your area. Well, guess what? We're going to make this a little trickier. We're going to add volume in there. And if you're guessing where this is going, this will actually make a lot of sense to you. If we have something that's 1 by 1 by 1, and we scale factor it by 4, right? We make it 4 times as large, so it's 4 by 4 by 4. What does that do to your volume? Well, finding your volume, you go 4 times 4 times 4, and you get 64 as an answer, centimeters cubed. Well, you probably see the pattern there. We're going to grab our scale factor, which we know is 4. We're going to cube it, and that brings us to 64 centimeters cubed. So scale factor and how that works to area and volume, you cube it and you square it. Cube it for volume and square it for area. So let's go to the practice set. So A, it says blueprints were drawn on a scale. Remember, scale, measure of 1 to 24. All right, so here it says if a length on the wall on the blueprint were 6 inches, what would it be in feet on the wall? Well, let's grab that and put that down. So we're asking what's it going to be on the wall in feet. But this is inches, so just remember that little tidbit. So in order to find our scale factor, you can see that we have to multiply by 6 to get to 6 here, which means we have to multiply this one by 6 as well. And that would get us our inches. So 24 times 6 would get us our inches. but we have to divide it by 12 in order to get our feet. Right? 12 inches is 1 foot. So this would wind up being 2 times 6, which is 12 feet. That would be your answer there. Hopefully that made sense as I walked my way through it. Okay, so for B, Brett is carving a model ship from balsa wood using a scale, there's your key term, factor of 1 to 36. Now it's going to ask us, okay, what's our measure? What measure do they give us? Right? If the ship is 54 feet long, how many inches is it? So let's get this right away to inches. 54 times 12 gets us to inches, right? And then we have to divide it by 36. Well, I try to make this simple here, so this becomes 1 and this becomes 3. So it really becomes 54 divided by 3, which is 18. So 54 feet works out to be 18 inches. Hopefully that made sense as we walked our way through this one. All right, so C says solve each problem by a scale factor. So it's 5 over 7 equals what over 15 over what? Well, because they're equivalent, there's one way to look at this one, and I'll expand it a little bit. So if we have 5 over 7 times what equivalent fraction equals 15 over 21? You can see we have to multiply by 3. 5 times 3 gets us to 15. So then we're going to multiply the bottom by 3 too. 7 times 3 gets us to 21. So if you can multiply it by an equivalent fraction, it's much easier than going 7 times 15 equals what? And then 5 times 21 equals what? And working your way through that way. So D is the same sort of thing. So D, what we have is x over 3 equals 42 over 21. We can actually flip this one around, or we can just work at what equivalent fraction can we divide it by. So if I look at here, we can go divided by 7. 21 divided by 7 equals 3. So 42 divided by 7 equals 6. And there's your answer. All right, let's move on to the next one, E. E says, these two rectangles are similar. Calculate the scale factor from the smaller rectangle to the larger rectangle. So remember what we did. 4 times your scale factor equals 10, which means that your factor is going to be 10 over 4, which equals 2. Oops. 2 and 2/4, which is 2 and 1/2. So there's your scale factor, 2.5. Okay, F. The area of the larger rectangle is how many times the area of the smaller rectangle? Remember we talked about that. It will be 2 times, 2.5 times squared, which equals 6.25. G. The scale of a model car in example 2 is 1 to 36, which means 1 inch on the grid, 1 inch on the model corresponds to 36 inches, that is 3 feet on the actual car. On grid paper, make a graph that shows this relationship. Make the units on the horizontal axis feet to represent the car, on the vertical axis using inches. So this one should be fairly straightforward to do. Let's just go put our grid on. So now we have our grid paper down, and we're going to make that work. So this is G. We're going to put our y-axis down, and then we're going to put our x-axis across. So on the bottom, they want it actually by feet. So we got 3 feet, 6 feet, 9 feet, 12 feet, 15 feet, right? And that has to do with actual size. And this has to do with the model car, right? So in here we would have 1, 2, 3, 4, and so on. So you can see that our scale factor will nicely pull through all of these lines here. Okay, and H. H says the statue of the standing World War II general is 1.5 times life size. Which is the most reasonable estimate of the height of the statue? So 1.5 life size. So if you imagine an average person, that would be myself, I'm 6 feet tall. So we have to multiply that by 1.5. Or another way to do it is 6 times 3 over 2, which I would get 6 times 3 is 18 divided by 2 is 9. I get 9 feet, so the answer would be C. So now I've been through it all with you, grade 7. Complete all of the even ones, and I will be on Google Hangouts Meet at 9:30 for you. Make sure you ding me